Welcome everyone. We are going to start with the topic of computer arithmetic, and before we look at the details, we first need to understand that numbers can be represented using different ways. So numbers can be either represented as an unsigned number or as a signed number. Within the signed number domain we have two options: signed magnitude number and signed 2's complement representation based number. So what is an unsigned number? Let's look at an example. So let's say I write a number which is 101.11. So obviously this number has the fractional part and it has an integer part, and this is basically your binary point over here. Now how do you understand this number? What is the value of this number? Value of this binary number? Obviously this is corresponding to a 2 raised to 0, which is a 1. I don't have anything here. This obviously corresponds to a 4, which is 2 raised to 2. This obviously corresponds to 0.5. This obviously corresponds to 0.25. So the total over here is going to be 5.75. This number now is a decimal number. The number given to you was a binary number. So this is basically the meaning of unsigned representation. Okay. Now similarly, let's look at the other two. So for example, the same number that we had earlier in this one, 101.11, if we take a look at the signed magnitude representation, it means that the first digit that you have over here is going to represent your sign. If it is a 1, it actually means that it has a negative sign. Whatever remaining digits that you have here are basically your magnitude. So the sign is stored separately and the magnitude is kind of stored separately. So then what is the magnitude of this part of the number? I have a 1 plus I have 0.5, I have 0.25. So effectively the number is 1.75. The magnitude is 1.75. In addition to that, the sign is saying that it is a negative number, which means the final answer is going to be minus 1.75. As opposed to signed magnitude representation, if we take a look at signed 2's complement representation, I again choose the same number over here, 101.11. In this case also the first digit is the sign indication digit. So if it is a 1, it means that it is a negative number, that is for sure. However, how do we calculate the value or the magnitude of this number? So what you then do as opposed to this one is that you take the whole number. You take the whole number to figure out what is the magnitude. You don't neglect this. You take the whole number. Start with the whole number. You take 1's complement of it, meaning you flip all the bits. So now if I flip all the bits, you are going to get 010.00. You are flipping each and every bit here. Plus you add a 1 to it. You are adding a 1 in the LSB position. Remember that. You are not adding a 1 at this stage. You are adding a 1 at the least significant bit position. If I do that, then obviously 0 plus 1 gives me a 1. 0, you get a 0, you get a 1, you get a 0. So what is the actual value of this number? This is then 2 raised to 1, which is a 2, and then this is 0.25. So the magnitude is going to be 2.25. However, the sign is telling that it has to be a negative number. So the final answer is minus 2.25. So we see that a number that we write as 101.11 in the unsigned domain has the meaning 5.75. However, the same number in the signed magnitude representation has the actual value minus 1.75, and the same number in the signed 2's complement representation leads to minus 2.25. So we have to be very careful when we are dealing with numbers, and we have to make sure that the number given to us or the number that we have to understand do we have to understand it as an unsigned number or as a signed number? And within the signed number, the more popular version is the signed 2's complement kind of a representation.